Welcome to the channel. This is Top Educator Akash. Today I am back with a new video of the physics chapter 1, that is electricity. So let us discuss the electricity chapter today. So I am back with the part 1 for electricity. So let us understand the concept with mind maps, animations and the concepts. So let us start the chapter electricity with introduction. So what is electricity? Let us study about the history of electricity first. As we know that electricity, the term is originated from the Greek words, that is electrica and electron. These are the words which are originated from the Greek words. So this electricity is originated from Greek words, that is electrica and electron. So basically there are two types of branches that is in electricity. The one branch is called static electricity and the other branch is called current electricity. So what is static electricity? So the electricity in which the involves flow of electrons or the charges which are in rest. The charges which are in rest are nothing but static electricity, and the charges that are in motion is nothing but current electricity. So today we are going to deal about current electricity. So this concept, that is static electricity, is not for us. So today we are going to deal that is current electricity. So let us start. So basically you also need to study about the frictional electricity. This is also a concept that is not there in our textbook. So nothing but the frictional electricity is nothing but there will be a change produced by the flow of nothing but transfer of electrons by shifting of electrons. So how it is produced? By rubbing two particles. So if any two materials in the series are rubbed against each other, then the element occurring first in the series will acquire positive charge and the element occurring later will acquire the negative charge. This means, so suppose let us take a rod and take a silver cloth. Suppose if we rub this silver cloth to this rod, so if we rub this silver cloth with this rod, so there will be some flow of electrons from this rod to this silk cloth. So here the nothing but shifting of electrons is taking place. This process is also called as induction. There is a frictional electricity produced. That means here we can observe that there is some of electrons that are moving, that is shifting from rod to silk cloth. Here both are obtaining the charges. One is positive and other is negative. So this acts as positive and this acts as a negative charge. So similarly, I will give you an example. Suppose while you are sleeping, suppose if you rub your hand with your blanket, you will see somewhat lighting is produced. What is that? That is nothing but there is flow of the charges, that is nothing but shifting of electrons took place there. So that is nothing but frictional electricity. This electricity takes place in basically many materials, like I have given these all examples you can observe here. So let's move to the next concept. So basically, what are the fundamental laws of electrostatics? What is meant by electrostatics? Electrostatics is nothing but a branch in the physics which deals with the study of charges, that is attraction and repulsion. So what are the charges? Basically there are two types of charges. How many types are there? There are basically two types of charges, that is positive and negative. So what happens when positive and positive is brought together? then there will be repulsion process. That is nothing but they will move away from each other. If negative and positive is brought, then they will attract each other. This is a property of the charges. So next, that is insulator and conductors. What are insulators and what are conductors? So the insulators are those substances that are bad conductors of charges. So how we can tell that there are insulators? That means they don't conduct any electricity are nothing but the insulators. Suppose I can give an example of plastic, or I have given basically in the previous part that silk cloth, it is also an example of insulator. So but it can be charged easily by friction. So I have explained it that if it is rubbed with a rod, then it can be obtained a charge, that is negative charge. So similarly, what are conductors? Conductors are those which will allow the charges to flow from them. Suppose you think iron material, when it is passed with the wire and it is connected to a battery, then the electron starts to flow from them. It is nothing but it allows the flow of charges. So why conductors have, you might get a question that why only conductors have loose electrons, or why it has flow of charges. So the reason is that the conductors, their atoms have the loose bonding in them. So the exterior electrons, that means valence electrons, that don't have much attraction towards the nucleus, so they lose from the atom and they freely roam here and there like you. So due to that, there will be some free electrons in the conductors. So when any source is brought near them, then it is charged and the electrons start flowing. So this is the reason why conductors are the good conductors of electricity. That means why they have the flow of charges. Now next concept, that is current. So what is current? Current is nothing but the rate of flow of charges. So what is current? That is nothing but rate of flow of charges. You are hearing a term that is rate. What is rate? So whenever a term rate comes, that means it involves time. So rate of flow of charge, that is nothing but, so in how many seconds the charges are flown, nothing but the current. So we have given a alphabet to charge. So to represent charge, we have given a letter that is Q, and the what is the SI unit of charge? Nothing but coulomb. The SI unit of charge is coulomb. And how it is named? It is named after a famous scientist who discovered it. It is nothing but Charles Augustin de Coulomb. So and T represents the time, as we know that. So I is the letter that is represented as current. So I will be equal to Q by T. That is nothing but current by time. So what we can, how do we can define current? That is rate of flow of charges are nothing but current. So what is the SI unit of current? Ampere. Ampere is the SI unit of current. Now what is the quantity? That is scalar quantity. Why current is a scalar quantity? So we are going to study about it deeper in the next 11th and 12th classes, but you need to remember just that it is a scalar quantity. Now you can visit our website to download the mind maps and the notes you can get from them. These are very helpful notes, as well as you can get the NCERT solutions. So let us study the further thing. You can observe here the electrons are flowing. These are the protons and these are the electrons. So this is the conductor. So as I said that it has free electrons, so these free electrons are connected to a battery. So conductor is connected to a battery. So due to that there is a flow of charges. So these charges are nothing but electrons. So let us go further. So this is the mind map that I have brought for you. That is complete chapter I have revised in this mind map. So no need to study anything textbook or no. It is very helpful in quick revision during the exams. So let us start the first, how to define the electric current. I have already discussed that the electric current is nothing but the rate of flow of electric charges is nothing but electric current, and the charges, what I have said that it is represented by Q, and the SI unit is Coulomb and named after Augustine D. Coulomb. And one more important thing, that I have said that there is a flow of electrons. So what is the charge on one electron? The charge on one electron, 1 minute. The charge on one electron, we need to study what is the charge on one electron. So the charge on one electron is minus 1.6 into 10 to the power minus 19 coulomb. So you need to remember this, you may get the question in the MCQ. So what is the charge on one electron? That is minus 1.6 into 10 to the power minus 19 coulomb. So what is the charge on one proton? So think, just pause the video and think. As we know that an atom is neutral. So why it is neutral? Only it is neutral because the charges are going to cancel out. How they are cancelling? If there are same charges, the value of same charges is same, so then itself it is going to cancel out. So we can say that plus 1.6 into 10 to the power minus 19 coulomb is the charge on one proton. So I have said that the charge on one proton and one electron. So next, what is the SI unit of current? That is ampere. And what is the formula? That is I is equal to Q by T. So there is also an important device that is helpful for measuring the electric current, that is ammeter. So ammeter is always connected in series combination. So this is the representation of ammeter in the circuit. So I have said that it is connected in series. So how it is series? What is series combination? Suppose this is a circuit and here is battery, and if I want to measure the amount of current flowing through the charge, I have to connect the ammeter in series. So how to connect the ammeter? That is plus and minus. So as you can observe here, this is battery and this is ammeter. So these are connected in series. How we can tell that these are connected in series? You can see that the one end, that is positive end, is connected to positive and negative end is connected to negative. That means these ends are not connected to each other. These are connected with different sources. So we can say that these are connected in series combination. Now next term, that is electric potential. This is very important term, that is electric potential. What is electric potential? So the amount of work done to move a unit charge from one point to another is nothing but electric potential. So as we have studied that what is electric current, so how these charges move. So there should be some amount of work done, that is there should be some energy done, so then itself they can move. So we can say that the amount of work done to move a unit charge from one point to another is nothing but electric potential. So how this electric potential is created? So as you can here observe, the charges are moving here, they are moving. So it is the series, the circuit is connected to battery, and you can observe here the electrons are moving. As the electrons move and come into this battery, again they start moving. So you can say that it is providing the energy to move the electrons. So suppose you observe this 1 minute animation, you will get the idea that suppose this is the circuit and it is battery, and when the electrons start moving, the electrons starts moving from higher potential. The positive side is said that it is higher potential and negative is said that it is lower potential. So the current direction is always from positive to negative. It is the conventional direction of current. So the electrons start moving, and you can observe here the electron starts, and here it moves, and finally it enters here it is entering. You can observe here the man is completely charged and he is moving fast, but as he soon reaches here, see, you can observe here he has become too tired. So again the energy is provided to him. Who is providing the energy? Battery. Similarly, similar thing happens in the circuit. When the electrons move and come here in the negative side, the battery is providing energy, again it is moving. So the similar thing is happening here. So the electrons are moving, and it is connected to a bulb, it is glowing, it is also taking some energy. So again it is moving, and finally here it reaches here. So it is reaching here. So the battery is providing some energy. This energy is nothing but potential difference, the amount of work done to move. There is some amount of work done, that means there is some displacement, and these are moving, that is with velocity. So this is nothing but amount of work done to move a unit charge from one point to another, that is potential difference. So what is the formula? Work done by charge, V is equal to W by Q. So what is the SI unit of potential difference? That is volt. Volt is the potential for SI unit of potential difference, and the formula to find the potential difference is V is equal to W by Q. So 1 volt, that is equal to 1 joule by 1 coulomb. So how we can define 1 volt? When 1 joule of work is done to move a unit charge of 1 coulomb, then we can say that there is a potential difference of 1 volt. So what is the device to measure the voltmeter? What is the device to measure electric potential? That is potential difference, that is voltmeter. So how it is connected? It is connected in parallel combination. So it is the representation, that is for this is the representation for voltmeter. So I will explain this. Suppose you think this is the circuit and it is connected here. Suppose you think it as bulb. Now it is connected here, and here you can observe this is connected V, that is positive and negative, and this is voltmeter. It is connected in parallel combination. This is nothing but the parallel combination. You can observe in the previous the ammeter was connected here, but it is connected with another end. That means these both end meet here. So this combination is nothing but parallel combination. So next term that involves is electric circuit. What is electric circuit? I have been using the word circuit. So what is circuit? A closed and continuous path of an electric current is nothing but electric circuit. So what are the electric symbols? The cell. So what is the symbol for cell? That is, you can observe here, the battery and the wire joint. That means the wire which are connected. It is the representation symbol. And wire with crossing without joining. That means they are not connected, they are just passing over. Bulb and resistance I will discuss you further. And this is wire, it is fuse. So this symbol is for fuse, and this is variable resistor. I will be discussing with you later. And it is switch symbol. That means button. Key, you can tell it as key. It is open and it is closed. So let's move to the next topic. So in the previous we have discussed that electric potential. So what is electric potential? I have said you before. So next term, that is Ohm's law. So before going to Ohm's law, suppose you think that there is some amount of energy flowing, some amount of electrons are flowing here. Now if I increase the current in the circuit, what happens? If I increase the current in the circuit, then the flow of electrons will also increase. So how to increase the current? Suppose if I bring, instead of 6 volt battery, if I bring 8 volt battery, so then there will be some more amount of work done to move the charge, so there will be much current in the circuit. So we can say that if the voltage, nothing but potential difference, is increased, then the current is also increased. So this statement, so what happens, the potential difference is directly proportional to current through it. So there is a condition that provided its temperature remains the same. So if the potential difference is increased, then the current is also increased. So V is proportional to I, that is potential difference is proportional to current. So as we said that it is proportional, so there should be some constant present here. So to remove that constant, we can write it as V by I is equal to constant, this constant, and this constant we can say that it is nothing but R, that is resistance. So V will be equal to IR. So another formula we got of potential difference, that is V is equal to IR. So potential difference is equal to current into resistance. So what is resistance here? I will be discussing this also. So the resistance is nothing but the opposition to flow of charges or current. This is nothing but resistance. That means, so the electrons will be resisting by the some external matters or something, the exterior parts that is not helping the electrons to flow, that is stopping the electrons, that is nothing but resistance. So let us discuss What is resistance? So the opposition to flow of charges or current is nothing but resistance. And what is the SI unit? So the SI unit of resistance is ohm. It is named after a scientist. Now, according to Ohm's law, we know that V is equal to IR. That means R will be equal to V by I. So we can say that 1 ohm, that is equal to 1 volt by 1 ampere. That means, so we can define that 1 volt by 1 ampere. Now there is also an important term, that is factors on which resistance depends. This question is compulsory for the exams, so please be prepared for these exams. So what are the factors that are dependent on resistance? That resistance will be dependent. So one is length of conductor. So what is that? That is length of conductor. And other is area of cross section, and other is nature of material, and the one more, that is temperature. So these are the terms that resistance will be depending upon. Suppose you think that here is a conductor. Now if I increase the length of this conductor, suppose it is, the length is L. Suppose if I increase the length, that is 2L, then what happens is that the resistance of it will also increase. Now if I take one more conductor, this is the conductor and its area of cross section is A, and if I increase the area of cross section, let us make it as 2A, then what happens is that the resistance will decrease. What happens? That the resistance will decrease. Why will it decrease? So how we will make it as 2A? That is by increasing the cross section. So by increasing the cross sectional area, then there will be some much space between the atoms, so there will be much free space. So there will be free space, so the electrons can move easily, so the resistance will decrease. Now next is nature of material. What is nature of material? Nature of material is nothing but resistivity. We will be discussing later. Temperature. If I increase the temperature, then the resistance will decrease. So now how resistance is proportional to the length, area and resistivity. So let us take R is resistance, and so the length is equal to R is equal to L by A into resistivity. This is rho. This resistivity is nothing but rho. Resistivity symbol is also called as rho. So R will be equal to rho L by A. That is, if length is increased and the resistance will also increase, and area is decreased, then resistance will also increase. That means if R is inversely proportional to A, and it is directly proportional to L, and it is dependent also on resistivity. What is resistivity? Resistivity is nothing but it is the nature of material. It is the characteristic property of material that depends only on temperature and material. It will not depend on resistance, nor it will depend on length and area. It will only depend on temperature and material. So if the material is silver, so suppose you think that the material is silver, then its resistivity will be constant. And suppose you think it is a gold, then its resistivity will be different. So we can say that the resistivity varies from material to material. So what is the SI unit of resistivity? It is nothing but ohm meter. So what is the SI unit of resistivity? That is ohm meter. So friends, I will conclude this session with these topics. So I will be discussing with you the next topics in the next parts. So thank you friends, and please subscribe to my channel and press the bell icon to get new notifications of new videos, and please don't forget to download this mind map. I will be given in the link description below.